Welcome to another exciting segment of Math with Miss Bennett. Today we're going to talk about surface area. Surface area is the combined area of each two-dimensional face or surface on a 3D shape. In the 6th grade, you often find surface area by looking at the net, which would be the two-dimensional version of a shape that you could fold up and it would become the 3D shape. I will draw the nets, but I'll also work without the nets for people who are never terribly comfortable with them in the first place. There is no formula. And if you find a formula online, except for the rectangular prism, it's often more complicated to memorize all these crazy formulas than it is to just find each area and add them up. So let's look at some surface areas. Here we have a square pyramid. If you were using the net method, you would draw the net, which would include a square and the 4 triangles such that they could fold up to make the pyramid. And in this case, you would see that the square is a 4 by 4. So those are the dimensions. Then you'd look at the triangles, and you can see that the triangles are all the same, and they have a height of 5. So here I draw one of my triangles with its height of 5. So I've got 5 areas to add up, 4 triangles and 1 square, which I can do from the net or from the shape. So I've got triangle, 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 and square to add up. My triangles all have the same area. 1/2 base times height, which is 4 times 5. 1/2 times 4 is 2. 2 times 5 is 10. So each triangle is 10. Now I need to find the rectangle or square. So the square has an area of 4 by 4, which makes its area 16. To find the surface area, you simply need to find the sum of all the areas. So I get 6 and 1, 2, 3, 4, 5, 56 meters squared. Because remember, surface area is an area. It's taking the 3-dimensional shape and flattening it to its net to find the area of the net. Let's continue. Here I have a rectangular prism, which is possibly the easiest one to find. I could simply draw the net. And we'll notice that our net will have 7 and 8. So these will seem about the same, but not quite. And I could do that. I'd have to label each measurement, which gets a little bit annoying, but we've got an 8 by 13 for the base. Making this one here the 7 by 8. Each of these rectangles also have 13, and that's 7, 7, 8, 8. Again, the net annoys a lot of people, but it works for others. My personal favorite way is to just take it one piece at a time. So I have the base rectangle. Alright, I changed my mind. There's my base and the top rectangle. I've marked it in blue. So I need to find the area of that rectangle twice because it's the same thing each time. I have the front rectangle. I need to find its area twice because it's the same as the back. And then I have the right rectangle, and I need to find its area twice because it's the same as the left. So, the blue rectangle has an area of 13 by 8. which is 104. And the other blue rectangle for the bottom is exactly the same. Now I need to find the area of the red rectangle, which is a 7 by 13 with an area of 91. And remember, that front rectangle matches the back rectangle. Now I need to find the area of the yellow rectangle, which is an 8 by 7. So 7 by 8 is 56, and the right rectangle matches the left rectangle. So I simply need to find the total area of all the faces. I often like to double the measurements that are doubled and then add up that. 8 plus 2 is 12 plus 2. 8 plus 2 plus 2 is 12. I'm ahead of myself. 8 plus 1 is 9 plus another 1 is 10. And 1, 2, 3, 4, 5. 502. So the surface area is 502, and this is inches squared. Not the neatest way to write my work, but it's there. And that's our rectangular prism. In my opinion, the single easiest surface area you can find. Here we have a triangular prism. The triangular prism has a net that looks a little bit like this. And you simply line up the pieces. So this would be my base one. And it is a 14 by 8. And the height of the triangle is 6. And it's the same for the other triangle. Alright, sorry guys, I realized I was missing some measurements for my triangular prism, so I had to label them for you. And then these two sides here are 7.2 and 7.2 because they come from the edges of these isosceles triangles. So let's find the surface area. We simply need to find the area of all the shapes. And remember, our shapes are 2 equal triangles and then 3 rectangles, which are not necessarily equal. These aren't equilateral triangles, they're isosceles triangles. I'm going to start with my triangles. Get the hardest part done first. The triangles have a right angle here, so you see that the height is 6 and the base is 8. 1/2 times 8 is 4. 4 times 6 is 24. So both triangles have an area of 24. Next, I'm going to look at my rectangles, and I have 3 I have to work with. I have the left rectangle, which if you look at its measurements are 7.2 and 14. .2 times 14 is 100.8. If we look at the next rectangle, we can see that has the same measurements as the last one. This is, after all, an isosceles triangle, so 2 of the rectangles connected to it are going to have the same length and width. And then finally, we have to find the area of this bottom rectangle. The bottom rectangle has an area of 8 by 14, which is 112. To find the total surface area, we simply have to add up all of our areas, which comes out to a total of 361.6 yards squared. Because remember, this is a surface area. It's a 2-dimensional measurement of the flattened version of the 3-dimensional shapes areas. Let's try another. Here we have the often dreaded triangular pyramid. So many triangles. It tends to make people very upset. Here we have a equilateral triangle that has all side lengths of 4.5 centimeters. The height of that equilateral triangle, it tells us, and this is my base triangle, by the way, is 3.9. Then around it, we've got some other triangles that happen to all be the same, because of the equilateral triangle that they're connected to. Each of these triangles has a side length of 4.5 for their base, and their heights are shown to be 3.5. And again, these pictures are often really tough to read, which is why I don't really like using the net method for these. So I've got 4 triangles to find the area of. The base triangle, and then the 3 matching edge triangles. And they're not always going to match, but they just happen to in this case. Triangle area is 1/2 times the base times the height. So the base of that triangle is 4.5, and the height is 3.9, making its area 8.775. Now I've got the triangles I've got marked in blue. Because it's an equilateral triangle base in dark blue, the light blue triangles are all the same because they start with the same base. So their area is 1/2 times their base, which is 4.5, and their height, which we're told is 3.5. And that makes their area 7.875. So these areas are all almost exactly the same when you look at the two, how close they are. Because all 3 of these triangles are equal, I'm just going to repeat these measurements. And then find their sum for the surface area. And their sum is 32.4 centimeters squared. Because remember, surface area isn't volume. It's a 2-dimensional measurement, not a 3-dimensional measurement. We would flatten it out to the net and find the area of the net. So back to our beginning slide, we found the surface area of all of our shapes. Remember that surface area is the combined area of each 2-dimensional face or surface on a 3D shape. You either draw a net or separately find each area, and there really isn't a formula except for the rectangular prism one. So with our square pyramid, we just found all 5 areas and added them up. With our rectangular prism, we found the 3 separate areas, doubled each one, and added them up. I did want to go back and show you that technically there is a formula. It would be 2 times the length times the width, plus 2 times the length times the height, plus 2 times the height times the width. And that's the surface area of a rectangular prism. But personally, I don't like memorizing a formula that I don't have to memorize when I can just find each area separately. Then we found the surface area of a triangular prism, and because it was an isosceles triangle and 2 of the rectangles were the same, it made for a much easier surface area. Then we found the always dreaded triangular pyramid, because there's so many different things to measure, so many different numbers, arrows going in and out of everywhere, and everything ends up being halved. These are messy, but they can be done. And we just added up all 4 of the areas, and thankfully this was an isosceles triangle, making these 3 areas all the same. Excuse me, not an isosceles triangle, an equilateral triangle. And that is surface area. It's not easy. Well, let me go back. It is easy, but it takes a lot of time. It's basically all multiplying, occasionally dividing by 2, and adding. And none of those things are hard, but it takes forever, and that's why people tend to not like it. But it is something you will see in your math, so it's important for us to understand how to use it. Thanks for joining this extra long segment of Math with Miss Bennett.